Welcome you all. In the today's session, I am going to explain you about the concept of arrays. Okay, this is the third module. Okay, so far we discussed the variables of type integer, char, double, and float, and variations of int and double. So all the variables are constrained. Okay, example, if you consider a variable of integer type, it can store only one value. If you consider the variable of float type, that also can store only one value at a time. But sometimes we need to store more than one value, or we need to perform process. We need to process more than one value, or we need to read and display more than one value. So, if you want to do more than one value process or more than n number of value process, it's not possible using a single variable. Okay, let's consider if you want to perform addition of two numbers, we can easily perform addition of two numbers by declaring a, b, and sum. Okay, we can write sum is equal to a plus b. If you want to perform sum of three numbers, then we can define n1, n2, n3. If you want to perform four numbers, then n1, n2, n3, n4. So we can declare four variables. Then we can read elements for four numbers by using scanf. Okay, either we can use one scanf for one number. Example, scanf %d address of n1, scanf %d address of n2, scanf %d address of n3, and scanf %d address of n4. Like that, we can write four scanf statement to read four numbers. Okay, if in case there is a situation you need to read 100 numbers, you need to read 100 numbers, and need to perform sum, addition of all numbers. Addition of all numbers. Okay, now if you want to read 100 numbers, now it is very difficult. Okay, if you use this similar approach, if I use a similar approach declaring 100 numbers, 100 scanf statements, and find sum and display, it is very time consuming and it's difficult to track if there is any mistake. Example, you need to write 100 scanf statement. If you made some mistake somewhere in the scanf, then your program will not work. So it's very difficult. So C supports one more data type, one more derived data type. The derived data type is called array. Derived data type called array. So in order to overcome the problem of single variable, we can use the variable of type array. So array is a derived data type. So this array variable derived from the basic data types, that is int, float, char, double, and other data types. Example, long integer, short integer, integer. Okay, like that we can use the array variable. We can store more than one value. Okay, now you consider an example. If you want to store the marks of 100 students, so you need to define 100 elements. So instead of defining 100 elements, we define one variable of type, then can store 100 elements. Similarly, we can use array for storing employee name or student names, student marks, temperature, collection of items, item cost. Like that, we can use array for storing the data sequence of data items. So an array is the basic definition of array is an array is a fixed sized fixed size sequence of data items of single type with single name. So array is a fixed size sequence of data items of single type with single name. So there are many definitions for array. Array is a fixed size, or array is a sequence of similar data items. One more definition for array is a sequence of similar data items with single name. So array is a fixed size sequence of data items of a single type with single name. Example, I want to store salary of 100 members. Now we can write salary of 100. Now there is only one single name salary, but it can store 100 members salary. It can store 100 items or 100 employee information. So each element is addressed by or indexed by subscript. Each item is accessed or indexed by subscript. It also called as index. Subscript or index. So here salary is a single name. It can store 100 items. Each item is indexed. Then that can be accessed by the subscript. Now this is size, so we can store 100 elements. By using the subscript, you can access the individual item. Okay, now you consider number. Consider the item or variable name number. Okay, here number of size, so it can store 5 numbers. Example 10, 20, 30, 40 and 50. It can store 5 numbers. So here each item, so this is item 1, 2, 3, 4 and 5. So in the array we can use the number index for accessing. So this first number in array start with 0. So 0, 1, 2, 3, 4. Okay, 0 indicates the first element, first number, then second element, this is third element, fourth element and fifth element. So by using the subscript, we can access the elements. So now I can write number of 0 is pointing to 10. Number of 1 is 20. Number of 2 is 30. Number of 3 is 40. Number of 4 is 50. So, first number, second item, third item, fourth item and fifth. So, here 5 numbers can be stored by using one name. By using one name, we can store 5 numbers. So, in order to identify each number, we use the subscript. So, here 0, 1, 2, 3, 4 is subscript. 0, 1, 2, 3, 4 is subscript. This is also called as index. Okay. In C language, array is divided into 3 categories. That is 1D array. 1D array is also called as one dimension array. 2D array and 3D array. 1D array, 2D array, 3D array. 1D array is also called as one dimension array, 2 dimension array, 3 dimension array. So, in our syllabus, there are only 2 types, that is 1D array and 2D array, one dimension array and 2 dimension array. So, one dimension array contains only row, and in 2D it contains both row and column. So, depends upon the need, depends upon the purpose, either we can use 1D array or 2D array. Okay. Okay, the first array is one dimensional array. It's also 1D array. So, 1D array is a list of items can be given a single name, with single subscript. So, 1D array is a list of items given a single variable name with single subscript. Means the array contains only one subscript is called 1D array. Okay. Example, in mathematical representation, sum is equal to summation of I is equal to 0 to n xi. So, here xi indicates ith element of x. Okay. Now, consider here the value of n is equal to 4 or the value of n is equal to 5, then here x can store the value 0 to n. 0 to n means 0 to 5. So, here x can be represented as x0. So, if x0, this is x1, is x of 0, then x of 1, x of 2, x of 3, this is x of 4, x of 0, x of 1, x of 2, x of 3 and x of 4. So, it can store 5 numbers. So, this is first number, second number, third number, fourth number, fifth number. Okay. Here instead of 0, 1, we can write x of I plus 1, x of I plus 2, sorry, x of I plus 1, x of I plus 2, x of I plus 3, x of I plus 4. So, here where I is equal to 0. I is equal to 0. When I is equal to 0, first number 0 plus 1, I plus 1 is 2. So, like that it performs summation of the numbers. Now you consider 1, 2, 3, 4, 5. 4, 5. Now 1 plus 2, 2 plus 3, 3 plus 4, 4 plus 5. So, when I is equal to 0, it consider 1. When I is equal to 1, so first element add with the second number. So, 1 plus 2, next 1 plus 3, next 4 plus 5. So, it performs summation of this number. So, here we use array for storing numbers and perform sum of numbers. Okay. Now, we consider one more number, that is number 5. So, when you're writing this, it consider an array of the name number. It can store 5 numbers. So, when you write this in computer, it creates 5 locations. It creates 5 locations or allocates 5 locations. It allocates 5 locations. So, this is 0, 1, 2, 3 and 4. So, in array the starting location is always 0. Starting location is always 0. So, this will be number of 0, then number of 1, number of 1, this is number of 2, number of 3 and number of 4. Number of 4. Okay. When you write like this, number of 5, it creates 5 location. The starting is 0 and last number is the size minus 1. Here 5 is size minus 1 is, here 5 minus 1 is 4. The last index is the 4. So, the fourth element, the fourth index is the fifth number. Okay. Now, I'll store some numbers. So, when you store the numbers, ten, 20, 30, 40 and 50. So, this is number 0, number of 1, number of 2, this is number of 3 and this is number of 4. Number of 4. So, it allocates 5 locations. So, 5 locations are allocated by the number 10, 20, 30, 40 and 50. So, after assigning the numbers, we can manipulate these values. We can manipulate value. Example, I want to add the first number and the last number. So, we can directly perform sum is equal to number of 0. So, number of 0 indicates the first number and number of 4 indicates the last number. So, sum is equal to number of 0 plus number of 4. So, here we are adding the elements of the array. Similarly, if you want to store the sum of two numbers to other array element, example, now I need to change the value of number. So, number of 2. Number of 2 is equal. Number of 2 is the difference of the second number and the last number. Second number and the last number. So, number of 2 is equal to number of 1 minus number of 4. So here the difference will be calculated and difference will be assigned to the location number of 2. So if you want to change the value of the number itself, so example, I want to add some number to number 3. So example, number 3 is equal to number 3 into 10. So now the value of the number 3 is multiplied with the number itself. So by using the subscript, by using the index, we can perform the manipulation. Now I want to display the number 1 value. So similarly, if you want to display this number, printf percentage %d, because it is an integer value, percentage %d number, just write a variable name and the index. Now it will display the value of number 1. So by using the variable name and the subscript, we can access the individual element. So by using the variable name with the subscript, we can access the individual value. So here the number contains only one subscript. The number contains only one subscript. So that's why this is called 1D array. Now number is the 1D array. Number is 1D array. Similarly, now I'll consider char okay. Now this is also array because this is the type of character. The name is the name, then size is not specified, then the value is MIT. So when you write this, the computer or compiler creates file location that is MITM, and the last location will be assigned with null. So this 0, 1, 2, 3 and 4. Okay, this is also an array, but this is in technical terms this is called as string. So here it is array of characters. So name is a variable which stores the character value. So that's why this is character array. Okay, it is character array. There is also one-dimensional array. The name is one-dimensional array. Okay, 1D array is a list of items. The list of items given a single variable name with single subscript is called one-dimensional array. So in one-dimensional array, it contains only one subscript. So in array, the starting location is always 0. And ending location will be size minus 1. So if we specify size is 10, then the last position is 10 minus 1. That will be 9. Okay, that is about 1D array. Okay, the next is the declaration of 1D array. So like that other variables, array variables also must be declared before use. So array variable must be declared before use. So the syntax of array is data type, variable name, then size, variable name and the size. So first this specifies the data type. So the data type may be a int, float, double, char, long int. So first the data type, next is a valid variable name and the size. So size specifies how many numbers we can store in the variable. So how many variables we can store in the variable. Example int num 10. Similarly, float values 20, double items 100. So here number is of type integer. It can store 10 items. Okay, now consider 10 items, so 10 nums. So it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, because 10 minus 1 is 9. So we can store 10 numbers. So here the size of each cell, each number, it depends upon the system type. If you are using 16-bit machine, the size of this location is 2 bytes. So the total memory for this variable is 2 into 10 bytes. So total 20 bytes of memory will be allocated. If it is 32-bit machine, then this will be 4 into 10. So total 40 bytes. So here in 1D array, the index is always start with 0. So when you performing the array operation, we need to be very careful. Here, if you specify num of 5, but when you performing operation, you consider sum is equal to num of 3 plus num of 6. So this statement return error because the number size is only 5. So we are specifying the subscript 6. So it will go out of the index. So that time it will return error message. So when you are writing the subscript index value, the index value must be within the specified size. So the index must be a positive number. So it is usually integer number. So index will be a integer number. Subscript will be of integer type. So here the number is more than 0, but less than the specified size. If it is go behind the size of the array, then it will return error message. Then here the size is a numerical value. Or symbolic constant. Example, Here I will define as define max 10, max 10. Now I can declare variable int num of max. Okay, this is also valid. Okay, max is a symbolic constant, the size is 10. Now if you write this int num of max, then it will create, or it will define a array variable of name num, and the size is max. The size of the max is 10. So it creates 10 locations. So starting index will be 0 and ending index will be max minus 1. Okay, this is a declaration of array variable. So the syntax of array variable declaration is data type, variable name, and the size. Size is the size numerical value or the constant value. So when you declare the array variable, the index is always start with 0. Index is always start with 0 and end with size minus 1. So in this example, I have declared the num size 10. So it will create 10 locations. It will create 10 locations, and the starting location is 0 and ending location is 10 minus 1, that is 9. So when we are accessing the array elements, the index or subscript must be within the range. When the index must be within the range. Okay. Here num of size, so it can store 5 elements. If you specify 6, it will return error message because it is go behind the index value. Okay, it go behind the index value, it return error message. Okay, next is the initialization of array variable. So like that normal variable, we can also initialize the array variable. So once we declare array variable, we need to initialize the array variable either at the compile time or the runtime. If you not initialize the array variable, then the array will store the garbage value. Array will store the garbage value. Example, int num 10. So it create 10 location. If you are not assign any value, then it will contain some garbage value. It contains some garbage value. So it contains the garbage value. So when you declare the variable, the array variable must be initialized. The initialization of array variable can be done two different ways. One is compile time initialization. And runtime initialization. Compile time initialization and runtime initialization. In the compile time initialization, the variable when we declare a variable, that time itself we assign the value. In the runtime, during program execution, we assign the values. During program execution, we assign the values. Okay, let's consider the variable initialization during compilation. So the syntax of variable initialization is data type, variable name, within the bracket size, within the bracket size, then is equal to V1, V2, V3, Vn and semicolon. So, where data types specifies the primary data type, that is int, float, char, double, then this is the valid variable name, then the size, so how many elements we can store, then this is the value list. Value list. Okay, here the value list are list of values must be separated by comma. Okay, here the syntax of variable initialization is data type space variable name size is equal to list of values or value list, and the value list or list of values must be separated by comma, Example int num of 10 close bracket is equal to 10, 15, 17, 21. Okay, here example int num 10 is equal to 10, 15, 17, 21. Now it store 4 values. Okay, here this is num 0 index 1, 2, 3, 4th index. This is 9th index because the size of the number is 10. Now the first location is 10, second location is 15, third location is 17 and 21. So next the array is left with 6 more locations. So the array is left with 6 more locations. So these locations, the remaining locations are assigned with 0. The remaining location is assigned with 0. Okay, this type of initialization is called partial initialization. Because the array is not completely initialized. So array is not completely initialized because the size of the array is 10, but only 4 elements are assigned. So the array size is 10, but only 4 elements are assigned. The remaining locations are empty. Then this type of initialization is called partial initialization. Okay. Next, here one more example. Int num of 3 is equal to 10, 20, 30. 10, 20, 30. Okay. Here the size of the array is 3. Then we are assigning 3 elements or 3 numbers. Then this type of initialization is called complete initialization. Because the size of the array is 3 and 3 elements are assigned. So that's why this type of initialization is called complete initialization. Next, int num without size is equal to 10, 20, 30, 10, 20, 30. Okay. Now here size of the array is not specified. The size is not specified. Size is not specified. Size is not specified. Now the size of this location, the size of this array is 3. The size of the array is 3 because we are assigning 3 numbers. Now the size of this array is derived from number of elements. The size of the array is derived from the number of elements specified in the initialization. Number of elements specified in the initialization. Based on that, the size will be derived. Size will be assigned. Okay. This is initialization of array variable without specifying the size. Initialization of the array variable without specifying the size. Okay. Next, here when we initializing the value, we must be very careful. First thing is here I am specifying the size. The size is 3, but we cannot assign more than 5. Size is 3, we cannot assign more than 3 value. If in case if we try to assign one more value, then it will return error message. So more than the size, we cannot initialize the values. More than the size, we cannot initialize the value. Then one more is here the data type is int. The data type is int. We need to initialize only integer values. We need to initialize only integer value. If you try to assign values, assign a value 30.30, so it return error message because the fraction values is not allowed in the integer variable initialization. So before declaring the array variable, before initializing the array variable, we need to decide type of value we are going to assign. Type of value we are going to assign, how many values we are assigning, that must be decided first. Later we need to declare and initialize the array variable. So when we are initializing the array variable, we need to know the type of value we are assigning. So when you are assigning the value, the values must be separated by comma. The values must be separated by comma. So we can initialize less than the size of the value, but we cannot initialize more than the size of the array. We can initialize less than the size of the array, but we cannot initialize more than the size of the array. Okay, that is about the array initialization. So the syntax is data type, variable name, within bracket size is equal to within flower bracket values. The values must be separated by comma. The values must be separated by comma. So here in this example, the array size is 10, but the value only 4 values is initialized. So this array initialization is called partial initialization because the array is not completely initialized. So in the second example, the size of the array is 3 and 3 values are initialized. Then this is complete initialization because the size is 3 and 3 elements are initialized. Then the next is the array initialization without specifying the size. So int num, size is not specified, equal number. So here 3 numbers are assigned, then the size of the array is 3. Then the size of the array is 3. Okay, next runtime initialization. Runtime initialization. Example, here in the compile time we initialize the value during the variable declaration itself, but in the runtime initialization the value will be assigned during the program runtime. Example, for I is equal to 0, I less than 10, I plus plus. Now ARR of I is equal to 0. Now the array is initialized with 0 during program execution. So here this loop will be executed for 10 times, 0 to 9. Then during the execution the value will be assign. Example, this the variable is array. When the value of I is equal to 0, then this will be assigned with 0. Then I value increment, I value is pointing to the next element, then 0. Next I value is increment to the next location, that is 2, then 0. Like that, it will assign the value during program runtime. Okay, that is runtime initialization. So we can also read the values to the array variable. We can also read values to array variable by using scanf statement. Example, I want to read value to the array variable num. Okay, now consider num of 5, %d, address of num of 0, scanf, %d, address of num of 4. So we can write 5 scanf statement to read individual number. So scanf %d num address of number of 0 and address of number of 4. So this also valid, but we need to write 5 scanf statement. So instead of that, we can use looping concept. By using looping, we can read the numbers and assign to the variable. For example, for I is equal to 0, here I need to read 5 elements. I less than 5, I less than 5, I plus plus, then scanf %d address of num of I. So this loop will be iterate. How many times? 5 times, and each element will be read and assigned to num. Okay, now consider my index value is 0, 0, 1, 2, 3, 4. So I is equal to 0. First it will execute scanf statement, scanf %d address of num of 0. So it will read the first element and num of 5. Now initial value is 0, num of 5 will be assigned to 10. Next I plus plus, now I is pointing to the next number, that is 1. Scanf %d, I will enter number 20. 20 will be assigned to number of I, num of I. So now I value is 1. I only is 1. So it assigned num of 1. Now num of 1 is 20. Next number I will enter 30. Now I is 2. Scanf 30. Num of I, num of 2 is 30. So like that, scanf will be executed repeatedly for number of times. Then number of times the value will be read and assigned to array variable. So we can initialize array variable during runtime, and we can also initialize during compile time. So this the value reading through keyboard, value reading through the keyboard.